Okay, so now we're going to combine the 3D method to help us do a slightly more complicated derivative, okay? So now we want to find the derivative of x to the 5 halves, okay? So the first thing you want to do is you want to split this into wholesome x's. What I mean by that is you have x times square root of x instead of x to the 5 halves, like that. So now let's draw this thing out. So the first dimension, second dimension, both of these are x. The third dimension is actually square root of x. So as you can see, I very cleverly put a little hook on there. Okay, so the area of this face is x squared. The area of this one is x square root of x. And so is this one. Okay, that's gonna be weird, but that's weird. I don't like it. I don't like that. That's better. Square root of x. Okay, so you pretty much do the same cube method. I'm just gonna draw the top so you can visualize what I'm talking about. So the top is actually has the same face as the bottom. So we have x square root of x. Let me zoom in so you can see the action. Okay, as you can see, bottom is x squared of x, so is the left side, the middle is x squared. So all I'm doing is redrawing this, and it's simply just the face cover. Okay, no. Now remember, we're expanding, except how much are we expanding by in this direction? Well, let me go back up here, right, my little expanding lines. Okay, so in this direction, we're expanding by dx. So it's the dx axis, and this is also expanding by dx, and right here we're expanding by the derivative, the square root of x. This will mess you up, or it messed me up. Okay, so we have dx on that side. This is not to my likings. Okay, so there. And whoa, what is the, oh yeah, this is dx too. This is tripped up. Like I said, you can do all of this with just 2 dimensions, but it's fun. Well, it'd be fun to know if like we had holograms or something. It'd be easier to do. But okay. Okay, so this is dx2. Oh no, it's not. No, it's not. This is the derivative of the square root of x. Don't do that. Derivative square root of x. And this little segment is dx. Because remember, dx is changing in this direction. Square root of x is changing in this direction. So that's why we have those like that. And this is x. Well, I'm just gonna label it. No, I don't know. I probably should I'll go back and label everything. So boom. And I'm going to draw the little axis so you know exactly what I'm talking about. Okay, so you see x square root of x. See all that? Well, you're going to see it again. X squared. This is x square root of x. Okay, so we got all this down. So now we just want to find out what the area of all this is together. And we know that all this is ultimately x to the 5 halves, the derivative of it. So let's begin our journey. Dx, so this Let's start with the faces. Why not standardize? So we have three faces. Oh, but we can't do that because one of the faces is different. This is x squared. So we actually have two faces right here that are the same. And what are they? Well, we know the area is x to the times square root of x. And we also know that they're both being multiplied by dx. You can see this one's multiplied by that dx, this one by this one. So we have dx right here. Now we're going to add the third face, which is x squared times the square root of, oh, I keep on falling for that trick, but it's not really a trick, the derivative of the square root of x. Okay, so you see that? And that's just for the faces. I'm not going to draw the little columns because like they don't, like the same reason they, as before. They have two items approaching infinity instead of just one, so they're much smaller in comparison to these two. And as dx does approach 0, they virtually approach 0 faster than these two. Okay. So now we actually, see, we have to know what the derivative of the square root of x is. So now you can look back at the other tutorial, just plug that in right there, and it's, actually, let's go through that real fast. So we know that the derivative of the square root of x is, okay, let me just do this real quick in my head. It's just 2 square root of x over dx, right? It's the derivative of it. So now all we have to do is plug that in right here. I thought something else was going to come up, but it didn't. Plus, I'm going to do, well, I'll do it the baby way since this is the first time you've seen this, but you should be able to do most of this math in your head, unless you haven't done it in a while. Okay, so you see right here, I simply replace that derivative with the actual derivative, and you see that when this square root of x, when you divide x squared by the square root of x, you end up with this right here. So I'm going to perform that real quick over here. You see, you can do the math later if you want to, and when you add those two up, you magically get the coefficient that you were expecting if you already knew how to do this, which is 5 halves x to the 3 halves. Oh, and you have to, okay, yeah, that, and you have to divide everything by dx. Just erase that. Why am I doing that? Okay, so boom. You see this? Zoom in, pause, contemplate, philosophize, and virtualize.